Hello everyone, welcome back to our course. Next, we are going to introduce ClickHouse, which is a column-based OLAP data warehouse. Here, we mentioned OLAP, which stands for Online Analytical Processing. So you can expect that ClickHouse is a tool used for real-time data analysis. At first, let's take a look at the overview of ClickHouse. Here we say ClickHouse is an open-source OLAP-oriented column-based database developed by Yandex. Besides, ClickHouse is independent of the Hadoop big data system, which means that it can be used out of Hadoop ecosystem. In fact, ClickHouse was originally designed to serve an analysis tool called Magica. Magica is also designed by Yandex, which is a famous search engine in Russia. During data collection, one click on a page generates an event that is a page-based click event stream. Then, the data warehouse performs OLAP analysis. Therefore, the full name of ClickHouse is derived from click stream and data warehouse. With the rapid growth of services, Yandex Magica has become the third largest web traffic analysis platform in the world. It processes more than 20 billion tracing events every day. The ClickHouse, which provides support for the platform, has a tremendous volume. ClickHouse has stored more than 20 trillion rows of data for Magica. 90% of queries are returned in less than 1 second, and its cluster size is over 400 servers. Although ClickHouse was originally developed for Magica, it is now widely used in dozens of other Yandex products because of its outstanding performance. And below, we can find some features of it. Like what we have emphasized before, ClickHouse has extreme SQL query performance, or namely, ClickHouse is extremely fast. Secondly, storage of massive data at extremely low costs. With well-designed column storage and efficient data compression algorithm, the compression ratio is up to 10 times, greatly improving the data storage and computing capabilities of a single node system, and greatly reducing the usage cost. This is an excellent solution for building a massive data warehouse. Thirdly, simple, flexible, and powerful. ClickHouse provides comprehensive SQL support, making it easy to get started. Flexible data types such as JSON, map, and array are provided to adapt to fast surface changes. It also supports approximate computing, complex data types, and probabilistic data structures to handle massive data processing. And on top of that, here we listed some other highlights of it. Firstly, complete DBMS functions. We say that ClickHouse has complete database management functions, including the basic functions of a database management system. Besides, it provides the cluster mode to automatically manage multiple database nodes. Secondly, column storage and data compression. ClickHouse is a database that uses column-based storage. Data in the same column is stored together, and columns are stored in different files. When executing data query, column-based storage can reduce the data scanning range and data transformation size, and improve the data query efficiency. Thirdly, vectorized execution engine. ClickHouse implements vectorized execution by using the SIMD instruction of the CPU. SIMD is short for Single Instruction Multiple Data. A single instruction is used to operate multiple pieces of data, and the data is parallelized to improve performance. Firstly, relational model and SQL query. ClickHouse uses SQL as the query language and provides the SQL query interface of standard protocol, so that existing third-party analysis visualization systems can be easily integrated with ClickHouse. Besides, ClickHouse also uses a relational model, so migrating systems built on traditional relational databases or data warehouses to ClickHouse is less costly. Fifthly, data sharding and distributed query. The ClickHouse cluster consists of one or more shards. Each shard corresponds to one surface node of the ClickHouse. The upper limit of the number of shards depends on the number of nodes. One shard corresponds to only one surface node. Besides, ClickHouse provides the concept of local table and distributed table. A local table is equivalent to a piece of data. The distributed table itself does not store any data. It is the access proxy of the local table and functions like the database sharding middleware. Distributed tables enable proxy access to multiple data shards to implement distributed query. And thanks to all the highlights we mentioned before, ClickHouse can be used in many different application scenarios. It is initially used as a web traffic analysis tool to perform OLAP analysis for data warehouses based on page click event flows. Currently, ClickHouse is widely used in internet advertising, app and web traffic, telecommunications, finance, and IoT. ClickHouse is very suitable for business intelligence application scenarios and has a large number of applications and practices at home and abroad. And here, we also list some other applications, like we can use ClickHouse to perform data storage and statistical analysis, advertising networks, RTBs, and e-commerce, log analysis in information security, detection and mining of remote sensing information, data processing and data analysis for online games, and so on. And the biggest application comes from Yandex Magica, a statistical analysis service provided by Yandex, which helps websites and mobile applications perform data analysis and refine operation tools. And also, we say that ClickHouse implements most of the current mainstream data analysis technologies and has obvious technical advantages. Compared with commercial OLAP databases, ClickHouse is open source and free. Compared with open source OLAP databases, most of open source OLAP databases cannot be used in large-scale internet services, and ClickHouse is far more mature and stable than these softwares. Compared with open source NoSQL databases, ClickHouse supports direct query from raw data. Besides, ClickHouse supports SQL-like language, which provides the convenience of traditional relational data. And compared with Hadoop ecosystem softwares, ClickHouse is a complete set of solutions on its own. Besides, big data processing in databases is easier to be performed with lower learning cost and higher flexibility. And finally, we can conclude this chapter by introducing ClickHouse open source architecture. Like all distributed systems, ClickHouse can be built up based on a large cluster of servers. But a ClickHouse cluster consisting of multiple nodes does not have a center node. Instead, it is more like a static resource pool. To use the ClickHouse cluster mode, you need to define the cluster information in the configuration file of each node in advance. After all involved nodes reach a consensus, services can access each node correctly. Actually, common database systems hide details such as data partitioning and replica storage below the table level, which users are unaware of. ClickHouse requires users to proactively plan and define detailed configurations such as data shards, partitions, and replica locations. This attribute, similar to manual mode, brings unfriendly user experience. Therefore, the ClickHouse instance of the MRS service packs these tasks in a unified manner and adapts them to automatic mode, which implements unified management and is flexible and easy to use. Alright, that's all for this chapter. In this chapter, we introduced what is ClickHouse, some features of ClickHouse, application scenarios of ClickHouse, the technical advantages of ClickHouse, and open source architecture of ClickHouse clusters. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.